My name is Justin Pappas. I am the lead level designer at OtherSide Entertainment. We are the rebirth of Looking Glass Games, which some of you guys might have heard of. Looking Glass made the original Ultima Underworld. They made Thief 1 and 2, and System Shock, to name a few. Right now, we are working on the next iteration of Ultima Underworld, Underworld Ascendant. Today, I'm going to talk to you about lighting for stealth, and I want to tell you a little bit about how OtherSide works first. At OtherSide, we're always trying to learn. We're always trying to learn new ways to do old things and interesting ways to do new things. So as we go through this, we're learning about stealth, and we're figuring things out, and we're throwing it against the wall, and we're trying it, seeing how it works. If it doesn't work, we move on, and if it works, we keep it. So we're still trying to figure out the best way to do this, but I thought I would share with you guys what our process has been and some of the learnings we've had along the way. So, Underworld Ascendant is an immersive sim, which presents a lot of unique design challenges in every area. Just to clarify what I think an immersive sim is not just a simulation, but an immersive sim is also immersive, meaning you are there. You feel like you are in that world. The world is believable and logical. And I think an important part of that is first-person perspective. A game can have sim elements, but be in third person, and that would just make it a sim, not an immersive sim. So first person makes it very difficult in a lot of ways for us to present readable information. Because a lot of what's behind you and to your sides is clipped out. So we need to communicate a lot to the player right in front of them. In an immersive sim, players need to have options. If they want to feel like they're playing as themselves, they need to be able to play any kind of style, meaning they need to be allowed to smash doors down and just go through them if they want to play aggressively, or they need to be able to, yes, sneak through the shadows and be sneaky and quiet and possibly non-lethal if that's how they want to play as well. And both of those things need to be fun, among other ways to play, right? And then within those ways to play, we also need options. So if a player is playing as a stealth player, we don't want them to just take the stealth path or take the brute path, right? Within that stealth path, we want them to also have many interesting choices along the way. These stealth options, pretty much any of the options, need to be totally unnecessary if the player doesn't want to engage it that way. And lastly, our lighting and shadow needs to feel real, and it needs to come from sources in the game world. We don't have lights and spotlights just sort of floating in space coming from nowhere. We're always trying to at least have a source so the player can see a light and find out where it's coming from. This is especially important in stealth if the player has water arrows and can extinguish torches. We like to call it carving out the darkness. So a player might enter into a brightly lit area and carve a path through torches that they can use to sneak past enemies. So one thing that's difficult for us is controlling the light, right? And trying to design a specific experience for the player that is under our control. We're finding wherever we turn, the less we try to control the player and just present a bevy of options to them, the easier it is for us and the more fun the player is having. But we still want to make sure that those stealth options are readable, something crisp and clear that the player can understand. How do we explicitly communicate that the player is hidden by darkness itself and not just by breaking line of sight, right? And I'm going to use sort of one of our training segments for stealth because I think that presents some of our core ideas around stealth that you guys can build upon in your own work. And I'm going to go through our process insofar as how we got to the final point that we're at now for our darkness stealth training room. Okay, so Thief, the Dark Project. How many people in here have played this game? Okay, a good amount. I think this is one of my most favorite games of all time. This game was the birth of the stealth genre. Its original game was Dark Camelot. After working on it for a while, they figured out that the most fun thing, the most robust system they had was the stealth system, and they stuck with that, and it became purely a stealth game. I don't think a lot of innovation in the stealth genre has happened, especially in the first person since then. I would love to argue about that. Any kind of innovations that have happened around stealth are generally around overt messaging, so exclamation points on the screen, or little boxes that the player can hide in. Press A to hide. Very overt communication there on what you can and can't do. Thief was much more fluid in the way you could move in and out of shadow, and the way you could choose which shadows to hide in, and the degree of how effective a shadow was going to be in hiding you. You weren't necessarily always hidden or not hidden. And part of that added to the tension, I think, in that you would sort of hide in a shadow as a guard walked by and just hope that he didn't see you. Though Thief did have a gem on the bottom that would glow dark or bright, depending on how visible you were. So in Thief, the dark areas are very clearly defined, as you can see here. It's like they're just painted on the ground. So back then, the real-time GI wasn't something that was really possible. And so they had it a little bit easier in that they could sort of fake shadows like this. So this is the stealth training segment from Thief 1, and it's super clear. You could, say, have a strip of darkness right through the middle to the goal there in the back. And then the player could, say, just walk down that strip, get to the goal, and not necessarily know that they succeeded because they didn't move over into the light. So you can see how Thief set up this zigzag pattern here that forces the player to navigate around the light towards the end goal there. So if the player did not fully understand the lesson, that being that the darkness itself was hiding them, then they would step into the light, and they'd get seen, and they'd have to try again. So our problem was, how do we communicate this explicit message and make sure the player does what we want them to do while using very realistic and modern-looking lighting? So first we sat down and we thought, what are our basic tools? What is the first thing you think of when you think of Thief and you think of stealth? And I think sort of the base thing was this concept of a column with a torch on the other side of it. And the torch casts a shadow on the other side of the column. It was super controlled, and it's super clear. Behind columns is where you hide. But it's not entirely exclusive from breaking line of sight, because the player could just hide behind the column if they wanted to without putting out the torch. The shadow's already there. It's also not entirely advantageous as far as extinguishing lights go, because again, the shadow is already there. So another way that we could do this was placing independent points of light, like this. And you can see here, we've created a sort of path around the lights. And so this was similar to Thief, in that you could come into the space and then had to make a decision which way to go around that middle light there. So this worked, but we were a little bit worried about it because it could very easily become very contrived. If we were doing this everywhere, it would become clear that we were just sort of placing these lights for design reason, and it would start to look fake. And as you can see here, some of the placement of these torches doesn't entirely make logical sense. So that's immersion breaking for us, and immersion is one of the key elements of an immersive sim. So before I get to what we eventually decided to do, I want to back up a little bit to one of our first core questions, again, around stealth. So we had to figure out what darkness was. I walked over to my leads and I said, "What is darkness?" And they looked at me like I was crazy. What we needed, though, what I meant was that we need a clear visual language for indicating what was a space that was safe to hide in, right? What was a more advantageous path the player might take? Of course, we started with pitch black. We'll just make darkness pitch black. The problem with that for us was that it was very easy for the player to get lost. Even if they just wandered into the shadow of a column and turned around against the wall where the shadow was, they would suddenly lose orientation, right? Maybe look at the floor and not realize they're looking at the floor because the whole screen was just pitch black. Never mind what would happen if the player extinguished all of the lights in the room. Then they would be completely trapped and totally out of luck. We could have solved that with, say, a light gem on their belt or a torch they could pull out, but that presented other problems that I won't necessarily get into, and we wanted to see if we could solve the core issue of lighting for stealth without those crutches. Another problem with day for night, before I move on to this, was that it was too high contrast. The blacks and the other colors were too much at war, and it looked kind of fake. It looked like a silk screen in a weird way. Another option for us was a bluish sort of day for night look. So films will do this a lot. They'll film during the day and put a blue filter over the camera, over the film in post-process to make it look a little bit more like night. Some other films do this better than others, and I thought this was a clear example. I have no idea what film this is from. Does anybody know? Okay. So that didn't work for us because of two reasons. Our first approach was to add dark lights. So if there were spots where there would be shadow, we had these bluish lights that were almost dark that we'd place in those shadows. We'd have dark lights under torches that would turn on if that torch was extinguished, so that now a dark light would be cast from that torch. So that was working a little bit for a while, but as the levels were rapidly changing and we were iterating back and forth on them, we kept having to move these dark lights around, and it was just too much work, never mind the cost of having all of these non-shadow casting point lights around. The other option for us was to use a flat ambient color, a deep dark blue, almost black. And this was great. You would never be fully in the dark. I didn't have to place dark lights, but that ambient color was the same tone all throughout. It was flat. It didn't really give a sense of depth. We had to go in and add some very light white fog in there to create a sort of atmospheric perspective, and everything was starting to look foggy and blurry, and it really wasn't giving us that realistic feel that we were going for. So then we found real-time global illumination, and this was our solution. This image, I think, is from a real-time GI, a Unity demo. It's beautiful. Does everyone in here know what real-time GI is? Anybody not know? Maybe you'd be embarrassed to raise your hand. Let me just explain it real quick. So real-time GI casts light around a room in a realistic way, in the way that this light is cast onto me and is bouncing off of me and casting colored light on the floor. Those blue lights are spreading out and bouncing off the curtain, casting blue light on the floor around it, even though that light is not directly cast at it. So another example would be a white table with a red balloon on it, and if you shone a light down on that red balloon, the color red of that balloon would seep into the white a little bit and make that more of a pinkish white. It would also sort of disperse and spread in a nice, soft, natural way. The problem with real-time GI for us was that it was very difficult to control. We could fake a lot of things, but we wanted to avoid that as much as possible. We wanted all light to come from sources, and we wanted it to look natural. We didn't want players to just use the breakage of line of sight for their stealth. We really wanted to go back to the feeling of playing a thief game and emphasize using the darkness. So again, how do we train that the player is hiding specifically in the dark without saying anything, without text or VO or anything like that? So this is what we came up with. What we have here is sort of a causeway divided on either side by glowing algae-rich water. The player comes in from the view here, and you can see right in front of them they have some water arrows. Ahead of them is a torch, and that torch is breaking a crisp, clean line of darkness. So we wanted the player to clearly see there was one path through the room, and it was in darkness. They could hide from the skeleton at the back there, but they would be seen if they walked into that light. You can see we fenced off the far side of the room there too, so they couldn't just jump in the water, go across, and climb up on and out. So we hint pretty clearly that we want you to use the water arrows. There's plenty of ways to put out that torch besides using the water arrow. You can shoot an arrow at its base. You can cause an explosion near the base, knock it into the water, and I'll let you guys figure out some of the other ways. So what happens when you shoot that torch, you see the path complete, and it becomes a little bit more explicit when you're walking through that it is the darkness that is hiding you. We use the water on either side, and as you can see, the causeway is raised so that the GI lighting wouldn't spill into the crisp break in the path of darkness there. So RealTime GI presented some really interesting solutions to the problems we were having, and created some fun stealth options that we didn't expect. I'm going to share some of those with you. So this is one of our early levels. It's the Ruins of Wern. If you guys want to try it, it's on a demo machine downstairs in the show hall under the Made with Unity, on the Made with Unity booth. So check it out if you have the time. So what we did here was we cast a really bright light from a crystal in the ceiling. And that bright light sort of shines right down in the center and calls that center out as a place where you're going to get spotted. We find that what players really like to do and what makes them feel sneaky is to sort of skirt around the outside of the intended playable area. So here is that in its purest form. We've got this big bright section in the middle. We've got some scary looking skeletons patrolling that section. And we try to make it very clear that if you walk in there, you're going to have to engage in combat. So more stealthy players might sneak around the sides and head into the sewers down there in the lower right, or up into the castle ramparts there. So one thing that was really interesting was the shadows that this big light would cast based on the RealTime GI bounce. So you can see those trees there in the foreground are creating some shadows there, so that if the player does get near the edge of this dangerous space, they might want to stick to those shadows or time very carefully when they're moving from the right to the left. Another thing we were noticing was that that big light would cast shadows into the castle in interesting spaces. So here we've got that light blending with a torch light, but still providing some nice color in the shadow itself. So we're going to keep experimenting with RealTime GI. We've tried some other interesting things. Not sure yet if they're going to be in the final game. Things like enemies with torches that are on patrols that might blast out your hiding spot with a bright spotlight, or flying enemies that also cast a pulsating light that might fly into your nice carved out path of darkness, among other things. So stay tuned to see what else we figure out insofar as what we can do with RealTime GI and realistic and immersive looking stealth. Thanks, guys. If you have any questions, I'd be happy to take them. They asked me to point you towards the two mics on the sides here.
I just had a quick question.
Hi.
So now that you're using GI for your shadows and whatnot, I don't think you can query that, like whether or not someone's like in a shadow. I don't know if you can, but I'm just wondering like how you determine whether or not the player is in a shadowed area.
I'm not sure how deep I can go into that,
Sure.
but we are doing that. We're measuring how much light is actually on the player.
Okay.
And then we are talking to a light gem. So we do have a thing on the screen that you can turn on that shows how visible or not visible you are, and that's actually based on how much light is on you at the time.
Okay, that's cool. Thanks.
Sure.
What about performance?
We don't talk about performance. No. Yeah, it does take a hit on performance. It's interesting. In some ways, it helps us. In some other ways, it hurts us. It helps us in that we can have fewer lights because one light, if it's bright enough, can fill a whole room with color. But it is difficult in that, of course, GI is very expensive and it takes a long time to build. But there are some guidelines you can follow. Right now, we're using a really low light map resolution. And we're finding that it still looks really great for us. And we're also going through and making sure that the radii of our lights are not overlapping at all. I think you're allowed up to 4 before it's a really intense performance hit. So we have a performance checker tool that looks for overlapping lights, and we go through and we tweak those accordingly. But you can be tempted to make your radii really big on your light to fill a big space. But again, with GI, you can have a smaller radius on your light and increase that bounce intensity, and it'll bounce even farther.
Thank you.
Sure. Anyone else? Sure.
There are any plans to port it to VR?
I can't talk about that yet.
Okay.
But I love VR, and I really hope, I would love to see it in VR.
Nice. Thank you.
Hi.
Hey, how do you ensure that for fast prototyping and level designers, this process is great or not? Because it might take a lot of time to rebuild every time, I guess. And
Yeah. That's been something we've been streamlining. So we started, and builds took about 16 hours to do. So I would do it at night before going home. And sometimes it would fail, and we'd sort of lose all that time. But we would just sort of factor in that we had to do this long build. There's a lot of things you can do, like using cookies on your lights instead of having them actually cast shadows of themselves. Again, reducing the overlap on radius, reducing the number of lights, but also going through and removing things from the static light build. So small items, cups and chairs. Well, maybe not chairs, but cups and dead fish and candles and vines and things like that. If you remove those from your static light build, that'll help your build go a lot faster. But really, you do just have to factor in that time that it's going to take. Another thing you can do is have a machine dedicated to building lights. Maybe work on 2 levels at once, work on one, send it off to build, work on the other while it's building, and trade back and forth like that.
thank you.
Sure. Any other questions?
How many bouncers for the lights do you use? Because, obviously, in my experience, the more bouncers you have, the harder it hits on performance, and after a couple, it doesn't really increase quality that much.
Yeah, I'd have to look at our settings to give you an exact number, but I think right now we're using just 2 or 3 bounces.
Yeah.
And sometimes we'll use more, like on that big bright light, we're experimenting with how much we can use without really blowing out the memory. But yeah, it really depends on the project. We have so much going on in our levels. We have to be as economic as we can with the GI.
Thanks.
Sure. Okay. Thanks so much.